Alright, this video is going to be a little review of right triangle trigonometry, so SOHCAHTOA, hopefully comes to mind. So first in your notes, we're just going to go ahead and draw a triangle and label what the trig ratios are. So there's a right angle, because it's right triangle trigonometry, so we have to have a right triangle to work from. So whatever side is across from the right angle is called the hypotenuse. It's also the longest side. And then to label the other two sides, we have to use one of the acute angles. It does not matter which one. I'm going to go ahead and label this one. So this is going to be theta. That is spelled T-H-E-T-A, theta. It's a Greek letter. So the side that's across from theta is called the opposite side. I guess you could say the side that's opposite of theta. And then the side that's next to theta is called the adjacent side, because the word adjacent means next to. So for SOHCAHTOA, hopefully this is a review. The SO is for sine. Sine of theta equals opposite over hypotenuse. That's SO. The CA part is cos of theta equals adjacent over hypotenuse. And then TOA is tan of theta equals opposite over hypotenuse. Now there are three more trig functions. They are cosecant, secant, and cotangent. So the first one we're going to look at is cosecant. If you want to write out the whole word, you can. Cosecant. That's how the whole word is spelled. Cosecant of theta is just the opposite of sine theta, so it's like if you flip it, so it's hypotenuse over opposite. Next, we'll look at secant. So SEC is the way that we shorthand it, but if you wanted to write the whole word, it's secant, like that. That's the opposite of cos, so hypotenuse over adjacent. And then last, cotangent, sounds like tangent, so cotangent. Theta is the opposite of tangent, so it's adjacent over opposite. Now, the way people have remembered these in the past, I think sine, cosine, and tangent, remembering that those are the originals, is not difficult. And the way that you can kind of remember which one goes with which one, tangent and cotangent are kind of obvious. Those ones make sense to go together. And then with the other ones, sine has an S, cosecant has a C. Those go together. And then cos has a C, secant has an S. So that way you have one C and one S. That's a good way to remember it. That's what has always helped me. All right, so we're going to find the 6 trig ratios for this right triangle I'm going to draw. This side is 3, this side is 4. There's theta right there. So if I look at this, the first thing I need to do is figure out what my hypotenuse is. Since this is a right triangle, I can always use the Pythagorean Theorem. A lot of you guys probably recognize that this is a Pythagorean triple, so that last side is going to be 5. I'm going to show you how to solve it by hand anyway, just in case you forgot. So a squared plus b squared equals c squared. 9 plus 16 equals x squared. 25 equals x squared, so x must equal 5. So there's the hypotenuse right there is 5. So if I'm looking for sine of theta, I'm going to get opposite over hypotenuse, so 3 over 5. For cos theta, I'm going to get adjacent over hypotenuse, so that is 4 over 5. And then for tan theta, I'm going to get opposite over adjacent, which is 3 over 4. And if you're not very good at just seeing these, just by looking at it, then you can always go through and label your triangle. Like I could label in the beginning, oh, that's the hypotenuse, that's across from the angle, so that's the opposite side. Oh, this is next to the angle, so it's the adjacent side. And then sometimes if you have them labeled, they're a little bit easier to write out. So sine goes with cosecant, so I'll go ahead and flip that, 5 over 3. Cos goes with secant, so that's 5 over 4. Cotangent goes with tan, so that's 4 over 3. Okay, let's do another one. So again, we're going to find all 6. I don't feel like writing the directions out again, so I'm not going to. There's our right angle. Here's going to be our theta. This side is going to be 3, and that side's going to be 8. This is not drawn to scale, because that side of 3 should be a lot shorter. All right, so to solve for the missing side, I'm going to say 3 squared plus x squared equals 8 squared. So that equals 64. So that means x squared equals, take away 9, 55. So x equals the square root of 55. That means when we do our answers, this time we're going to have some radicals in there. And so we're going to have to be careful that our answers are proper. All right, so I'm going to write out each of these. So sine theta, and we'll go ahead and hypotenuse, opposite, adjacent. So opposite over hypotenuse, 3 over 8. Cos theta is adjacent over hypotenuse, so adjacent is root 55 over 8. And then last, opposite over adjacent, 3 over square root 55. Now we can't leave square root 55 on the bottom of a fraction, so I have to multiply the top and the bottom by square root 55. So tan is actually 3 square root 55 over 55. So that's not my final answer. All right. Now we can just go ahead and flip each of those. So cosecant, we'll just flip 3/8 and make it 8 over 3. For secant, when we flip it, we get 8 over the square root of 55. We're not allowed to have that as an answer, so I'm going to multiply it by root 55 over root 55. So the actual ratio is 8 root 55 over 55. And then last, for cotangent of theta, don't flip this one. If you go back to the original one that you had, then it's going to be root 55 over 3, which we're allowed to have. So I'm going to leave this as root 55 over 3. If you had flipped this one right here, then you would have had to simplify the problem all over again, and it would have made your life a little bit harder. All right, and then last example, we're going to solve for the missing side. So here's a right triangle. That's the 90-degree angle right there. Up here we have a 58-degree angle. Over here we have a side length of 9, and then down here we have a side length of x, and that's what we're solving for. So when you approach these problems, first you want to see what trig ratio you can use. So you have to figure out what sides you actually were given in the problem. So here's the opposite side, here's the adjacent side. So you have to think which trig ratios use opposite and adjacent. So you have tan and cotangent. Those are your options. We'll usually stick to the original 3 because it's easier for us. So we're going to say tan of, instead of theta this time, we know the degree measure, it's 58, equals opposite, which is x, over adjacent, which is 9. So to solve this problem, we just need to solve for x. And so I'm going to multiply by 9 on each side. Multiply by 9, multiply by 9. Make sure your calculator can be in radians or degrees. Obviously, since we're talking about degrees here, should have labeled that, you want your calculator to be in degrees. And if you have your calculator in degrees, you're going to find that x is approximately 14.403.